For decades, string theory has been held up as the candidate for a theory of everything. We've been told again and again that this is the fundamental layer of reality. But what if that's not quite right? What if the theory isn't describing reality itself, but just a shadow it casts?
So let's just dive right into this, because this one question, it changes absolutely everything. What if, for all these years, physicists have been brilliantly and accurately describing the shadow on the wall, without ever realizing they're not looking at the object that's actually casting it?
Now, to really get this, let's do a quick refresher on why string theory was such a game changer in the first place. Standard physics sees fundamental particles as these little zero-dimensional points. It works for the most part, but it leads to some, well, mathematical absurdities, like infinities popping up all over the place. String theory's genius move was to ask, what if particles aren't points but tiny one-dimensional vibrating strings? And just like that, the math smoothed out beautifully. But this elegant solution came with its own set of really bizarre baggage, a whole list of puzzles that, honestly, have never been properly solved. Like, why does the math demand 10 or 11 dimensions? Why are these strings always vibrating? How in the world does gravity just emerge from the equations for free? And the big one, why can't we actually detect any of this? These aren't just problems, you see, they're clues. And all those clues point toward a radical new way of looking at this. The idea that strings aren't fundamental things at all. They're in effect an artifact of a projection.
And here's the core idea from this Dual-Caustic framework. What we call strings are actually imprints. They're patterns left behind when a deeper reality interacts with our own. And that deeper reality, it's called light. Now, it's really important to get this. We're not just talking about photons here. Light, in this context, means the complete, unmeasured, whole reality that exists before anyone or anything tries to observe it.
And this is a brilliant way to picture it. You've seen this, right? The beautiful, dancing, shimmering lines of light on the floor of a swimming pool. Those lines, they aren't things. You can't reach in and grab one. They are projection effects, these incredible interference patterns that are created as sunlight passes through the shifting, wavy surface of the water. The idea here is that strings are the cosmic version of that exact same phenomenon.
Okay, so to really understand how this projection happens, we need to look at the three layers involved. You've got the source of the light, the screen it lands on, and this really critical boundary that sits right in between.
First up, you have the light. Again, think of this as the ultimate source code. It's the complete, unbroken, continuous wave of reality in its purest, unobserved state. It contains all the information of the entire universe, whole and undivided. Next, you have the Barzakh. This is the critical boundary, the filter between those two layers. You can almost think of it as the very act of measurement itself. That's the moment a wave of infinite possibilities collapses down into a single, concrete outcome that we can actually see and touch.
And finally, there's matter, which is our measured reality. This is the screen where that projection lands, but unlike the continuous light, our reality is fundamentally discrete. It's pixelated. It's a sampled version of the whole thing, kind of like how a digital photo is just a sampled version of a real-life scene.
So let's put it all together. Here's how it works in 4 steps. First, that whole continuous light approaches the Barzakh boundary. Second, it gets forced through this filter of measurement. As it passes through step 3, the information interferes with itself, creating all these complex patterns. And finally, step 4, these patterns, these caustic traces, get imprinted onto our discrete material reality. And that is what our mathematics has been identifying all along as vibrating strings.
Okay, so if that's the real process, let's circle back to those enduring puzzles of string theory. Because honestly, when you look at them through this new lens, they suddenly stop looking like puzzles and start looking like logical, even obvious consequences.
All right, first up, the big one. That strange requirement for all those extra dimensions of space. Where are they? Why do we need them?
So string theory assumes these are extra physical dimensions, like tiny hidden rooms all around us. But the Dual-Caustic view says, no, that's not it. They're not dimensions of space at all. They're actually better understood as dimensions of information, what the theory calls phase dimensions.
I love this idea of bookkeeping. Think about it like this. When you project a 3D object onto a 2D piece of paper, you lose information, right? You lose all that depth. Well, the math of string theory is basically trying to account for all the information that gets lost, all those hidden degrees of freedom when the continuous light gets projected onto our flat reality. The extra dimensions? They're just the mathematical filing cabinets it creates to store all that missing data.
They're not extra rooms in space.
Okay, next puzzle. That constant mysterious vibration. Why on earth should the fundamental building blocks of the universe be oscillating all the time?
The answer is so simple, it's beautiful. It's just a rule of projection. Think about trying to draw a perfect smooth circle on a pixelated computer screen. You can't do it perfectly. You get those jagged edges, that stair-step effect. Well, at the smallest possible level, that's a kind of digital vibration. The vibration of strings is the exact same kind of artifact. It's the unavoidable static you get when you force a smooth, continuous wave of light onto our discrete, pixelated reality.
And finally, the ghost in the machine, gravity. Physicists were of course thrilled when gravity just fell out of their string equations without them even asking for it. But why is it there?
Well, in this view, gravity isn't a force carried by particles at all. It's the physical stress on the fabric of space-time itself. It's like pressing an object onto a stretched rubber sheet. Wherever the pressure is most intense, the sheet curves the most. Gravity is that curvature, caused by the immense pressure of light being collapsed and projected into our reality. And you know what? This also neatly explains that last puzzle, why we can't see the strings. It's because they aren't things in our reality. They are the boundary event. We only see their effects, just like we see the patterns on the pool floor, but you can't actually pick up the pattern itself.
So let's put this all together. What does this massive shift in perspective actually mean for how we understand reality? Let's just look at this side by side, because it really clarifies things. Standard string theory says strings are fundamental, and reality is built from them. The dual-caustic view says no, strings are just the visible artifacts of measurement, and our reality is a projection of a deeper reality called light. In one, gravity is a property of strings. In the other, it's a physical stress caused by the projection process itself.
And this brings us to what might be the final verdict. String theory isn't wrong. The math is incredibly elegant. The predictions are consistent. But it may be, as the theory says, ontologically mislocated. In other words, physicists have perfectly described the properties of the shadow on the wall, but they've mistaken that shadow for the fundamental object of reality.
And that, of course, leaves us with the ultimate question. If what we experience every single day, every star, every atom, every single person, is a projection, just a complex, beautiful pattern on a screen, then what exactly is the light? What is the true, whole, and unmeasured reality that is casting this incredible shadow we call the universe?